This is what we have covered. Limit extends to A. Okay, that's what this symbol means. Okay, limit extends to A. That means actually x takes values close to A. X tends to 2 means x is taking values close to 2. Okay, so just a symbol. Can I switch on the light? So suppose you want to find out limit extending to 2 of some function. If it is a polynomial function, you can just substitute x as 2 and get the value. If it's a polynomial function or any known function which is established to be continuous or known to be continuous, you can just substitute the given value, the functional value, whatever you get, that is supposed to be the limiting value. So for continuous functions, this method always works. Just have to substitute the value and get some numerical value that is supposed to be the limit value. So I've just shown some examples of continuous function. Then the method of finding a limit. That's what we discussed. In some functions, when x tends to 1, for example, in this function, x tends to 1. But when I substitute, I get 0 by 0. Okay, so I need to resolve this. So how I resolve? The first method to resolve would be to try factorization, which is very effective for all algebraic functions. So what I do, I succeed in factorizing this. Factorize the numerator and denominator. I factorize numerator and denominator, then got x minus 1 cancel. With the remaining functions, I substitute x as 1. I get a finite value. That is supposed to be the limiting value. So factorization is one method by which any problem indeterminates can be handled. 0 by 0 is supposed to be an indeterminate. Anvita, you are aware of that? Oh, you've had this topic already. Okay, so we have seen several examples where factorization helps in resolving 0 by 0 forms, and we get finite forms. The next method, what is the next method of resolving 0 by multiplying and dividing by conjugate? Okay, that will resolve the 0 by 0 in some cases. So after multiplying and dividing by conjugate, the trouble giving factor will get cancelled, and in the rest of the terms, we'll substitute x as 2 and we get a finite answer. So we consider it to have been resolved. So either you can factorize or you can multiply and divide by conjugate, or there is yet another method which we discussed. So I'll just recall the second method, which is missing here. The second method of resolving 0 by 0. Broadly, whenever you come across 0 by 0, there are, for algebraic functions, there are 3 options available. One is very effective, which is factorization. Okay, factorizing always resolves 0 by 0. Or you can multiply and divide by conjugate in case if it is irrational. And the third method is to use a very special result, which is known as limit extending to a, x power n minus a power n by x minus a is n into a power n minus 1. So there are 3 methods of resolving 0 by 0. So in one of these, you will be able to resolve it and it will click. The third method is very handy, especially it works when you are unable to factorize because of huge powers or fractional powers. So, shall I give you some problems based on this? Just try these. First, you have to substitute as such and see. Okay, those are absent for the previous class. You have to substitute as such. If you substitute, when you substitute x as 0, what do you get actually? Root 1 minus root 1, right? Root 1 minus root 1. So you have to first ensure this, that you get 0 by 0. After that, only the problem of resolving arises. You have to multiply and divide by conjugate of both numerator and denominator. They're not same functions. So 1 plus x square in the numerator, 1 plus x cube in the denominator. No, it's not taking the value 0. It is tending to 0, right? X is tending to 0. It takes values close to 0. That's why you have to listen to the previous video. Only then you will understand the concept. Simultaneous. Provided you don't get confused. Otherwise, you do it in stages. I don't mind.
Is the answer 1?
Did anyone get 1 as the answer? Swati gets 1. First, I'm multiplying and dividing by the conjugate of numerator. But I know that denominator is also irrational. So let me simultaneously work on rationalizing the denominator. Did you all see? We are not affecting the equilibrium. We are multiplying and dividing. So it's like multiplying by 1, right? So I think this method is actually for rationalizing the numerator. These two can rationalize the numerator. 1 plus x square minus of 1 plus x. We all follow? I'll retain the third term as it is. That's not helping in any manner, not in rationalizing. So that's a separate term altogether. And similarly, these two, this and this. All right, those two can help in resolving this. So it will become 1 plus x cubed minus of 1 plus x. And this term, I may have to retain as such. Tell me what will happen to this? 1 and 1 will get cancelled. I'll get x square minus x. And here, again, 1 and 1 will get cancelled. I'll get x cubed minus x. And these terms. In the midst of all these, I think we shouldn't forget there is some limit that we are considering, and the limit has not yet been applied. So limit has to be retained. Otherwise, whatever we do will be meaningless. The limit has not yet been applied, right? What do we do after that?
Good evening, ma'am.
Good evening, Prana.
Sorry to join late. I had some connecting issues.
Yeah, I could understand. In the top, I can take x out. That's one method of factorizing also. Yeah, here comes the breakthrough. X and X, they get cancelled. Okay, that was actually causing the trouble. The reason why both numerator and denominator were becoming 0 was because presence of X in the numerator. So that has been resolved. In the rest of the terms, you can substitute X as 0 now. Substitute X as 0. So you get minus 1, minus 1. And here root 1 plus root 1. Root 1 plus root. Yeah, ultimately it seems to be 1. This is the way you have solved, Swati?
Yes, ma'am.
Okay, good job. Yeah, of course, it turned out to be long because we had to rationalize both numerator and denominator. So it was somewhat long. Shall I give you yet another problem like this? Can you try? Let me know if you have copied after that. I'll proceed. Have we copied? Extending to 8. Did it yield 0 by 0? Could you check that first? Huh? See, that's mandatory. See, don't assume that it's already 0 by 0. Many of you will do that, I know. A plus 2A. Do rough work here. Okay. Yeah, indeed 0 by 0. So that necessitates multiplying and dividing by conjugate.
Is the answer 2 by 9?
2 by
9.
2 by 9. I think so.
Ma'am, I got 2 by 3 root 3.
2 by 3 root 3.
Yes, ma'am.
2 by 3 root 3. Maybe.
Yes, ma'am. Yes, ma'am. It's 2 by 3.
But the answer, that's right. Dhiren, what did you get?
Doing,
And-
ma'am.
Doing still. Okay.
Ma'am, it is 2 by 3 root 3. I took it outside the root.
Oh, you also got that, Vaishnavi?
Yes, ma'am.
I think this is staying. And this one is staying. Oh no, this one. Oh, that's correct. Yeah, this was giving trouble. Always remember when you multiply and divide by conjugate and factorize, the trouble giving terms, both in numerator and denominator, will vanish. So 0 by 0 is bound to go. Okay. So what is remaining is root of 4a plus 2 root a divided by root of 3a plus root of 3a. But already there is a 3 over here. Okay. So what is it ultimately? 1 by 3 into 2 root a plus 2 root a, 4 root a by root 3 into root a, 2 root 3a. 2 root 3 root a. Is this what you get? 2 by 3 root 3. How many of you got this? Excellent. Excellent. So many of you. Alisha. Yeah, Alisha is very systematic. How about you, Deepesh? Vaishnavi also, right? I think she got in the beginning. So find out why you're not getting it, because the concept is simple. It's just that you're multiplying, dividing by both the conjugates. And one conjugate will be useful in rationalizing, the other will remain, that we have to retain. Apply the limit there. Okay, understood? Okay, let's do one more problem like this. Problem number 3. Here there is no conjugation involved, right? Because there is no irrational expression. But I gave you 3 methods of resolving. Factorize. Yeah, try to factorize both the algebraic expressions.
Ma'am, is the answer -1?
Very good. Got it?
I also got -1.
Very good. Yeah, here also many got it. So this is relatively simpler, because you can factorize as you would factorize a cube minus b cube. We all know that a minus b into a square plus ab plus b square. And this one can be handled by splitting the middle term. Minus 2x minus 5x plus 5. So 2x into x minus 1 minus 5 into x.
Ma'am, I got 11 by 2.
Is it 11 by 2?
And I'm getting 11 by 2.
Ah, okay, then it must be true. How did you resolve, Swati?
I divided by x plus 1.
Oh, very good. Numerator numerator is a cubic polynomial, but it vanishes when you substitute minus 1, isn't it? So that means what? According to factor theorem, if p of minus 1 is 0, then x plus 1 is a factor. We all know that simple fact. So she says we have to divide it by x plus 1. So let's see the quotient x square times x cube plus x square. So when you subtract, get x square minus 10x. So plus x square plus x minus 11x minus 11 minus 11. So the remainder has got to be 0. Otherwise, there is something wrong with your factorization. So limit extending to minus 1. This can be factorized as x plus 1 into x square plus x minus 11 divided by, these two will get cancelled. Now you can substitute minus 1 plus 11 by 2, isn't it? It's 1 plus x, so it will be 1 plus 1 minus 1. X is minus 1, right? X tends to minus 1. What was your answer? 11 by 2 only. Okay. I think 11 by 2 only they said. No, how many of you got 11 by 2? Got it, is it? Yeah, are you okay with these two methods? Hmm? Problem number 5. We are still in algebraic limits. What were the three methods I was telling you? One was factorizing, other was multiplying, dividing by conjugate. These two are not going to help. The third method, extending to a, x power n minus a power n by x minus a is n into a minus 1. This is the last method. Okay, but we seem to have, in the result, we seem to have a monomial. So substitute 1 plus x as some y. Okay. So when x tends to 0, y will tend to 1. So the new limit applied will be y tending to 1, y power 8 minus 1. X is nothing but. Now it can be said that this can be applied because they look alike. Okay, both these forms look alike. And here it's important for you to make out. Can you all say this one is nothing but 1 power 8? So it will absolutely resemble this result in every possible way. So our job is to pick your A, and what is A? A seems to be 1, N seems to be 8. Okay, once you pick this up, you can apply the result here. 8 into 1 power 8 minus. Understood? So this is the way we resolve. So always remember. Yeah, you can. But I thought will absolutely resemble what's given. Excellent. Trial and error only because it's exponential equation.
Is it 5?
Good job. Yes, Neera. Can you all make out that this is exactly the replicate of that? Okay, same as that. And we know that the result has got to be n into a power n minus 1. Given. Okay? The result has got to be n into a power n minus 1, but that's given to be 8. Trial and error tells you that n has got to be 5. There's no other way of solving exponential equations. They're not quadratic or cubics. Okay, they don't have methods. So by trial and error only we can solve. Are you okay? So algebraic limits will necessarily come under one of these methods. Either you will try factorizing, which is the most effective. It works in most of the cases. Otherwise, if it's irrational, you will multiply and divide by conjugate. The last resort is to use this method. Okay, so it will come under one of these categories, I'm sure. Next. Let us pass on to trigonometric limits. Here, it's important for you to understand some results like limit extending to 0 of sin x by x is 1. This is the most important result. And then you have another result, which is also equally important. Limit extending to 0 of tan x by x is 1. Limit extending to 0, 1 minus cos x by x is 0. Limit extending to 0, 1 minus cos x by x squared. These results will mainly help. Plus, of course, your knowledge in trigonometry, like various formulas, like sin C minus sin D, all that. So actually, if you ask me, how do you get all these results? Let's take the first result itself. Limit extending to 0 of sin x by x. What I'll try in every limit problem, what I'll first try is to substitute, okay, the given value there. So what do I get? Sin 0 by 0. But we know sin 0 is 0. So it's becoming 0 by 0, which is indeterminate. So I have to resolve it somehow. What is the method of resolving sin x by x? Those who have done the topic already. Kalani, you have done the topic. Anyone else who has done this already? How do you prove? They haven't taught proof. Oh, they gave the result. All right. There is a series for sin x. Okay? X minus x cubed by 3 factorial. It's called Taylor series. X power 5 by 5 factorial and so on. Whole thing divided by valids for small values of x. But of course, here x is small. X is tending to 0. What is common in numerator? X. Prove. Have you understood? So this is the simplest way of proving. So sin x has got this expansion. But of course, you know this only if you know what is exponential series and logarithmic series. Fortunately or unfortunately, they deleted that topic. Okay, for you. You don't have it anymore. In Shankara, they used to teach this topic every year. But now, I think nowadays they're not teaching. No? They used to teach this topic even after it got deleted from the syllabus. Of course, it has no other particular interest except in proving this particular result. It will be useful if you know the series, Taylor series for sin x. So we can prove every other result using this. If you prove sin x by x is 1, the result of the rest can be proved using this. For example, look at the second one. I want limit extending to 0 of tan x by x. So if I directly substitute, I'll get tan 0 by 0 which is yielding 0 by 0. So I need to resolve it. So what I do is I write tan x as sin x by cos x by x. And in the next step, I can realize that it is the product of two limits. See whether you follow. After that, we'll proceed. Tan x by x can be written as sin x by x into 1 by cos x. Do you follow that? And according to the previous result, which you have just seen, what is sin x by x? 1, isn't it? Sin x by x goes to 1, provided x is small. So x is tending to 0 here. So 1 into 1 by cos 0. Understood? So result. Can you take down this proof? This result. Limit extending to a of f of x into g of x is limit extending to a of f of x into limit extending to a of g of x. Limit of product is product of limits. Limit of sum is sum of the limits. Limit of difference is difference of the limits. Limit of the quotient is quotient of the limits, provided the denominator is not 0. Okay, understood. So all these results are valid fundamental theorems in limits. Okay, so we can take a limit of a product as product of the limits. Okay, so I didn't show it, but actually what I did was, this is nothing but limit extending to 0 of sin x by x into limit extending to 0 of 1 by cos x. However many products you may have, apply limits to them individually and then multiply those limiting values, you get the ultimate limit. So that is the principle here. So 1 into 1 by cos 0, which is understood. So that is the proof for tan x by x being 1. That was the second result. Okay, let's take the third result. If you have these results handy, then you can prove most of the problems. Okay? I have to prove this to be 0. Okay, the proof. Okay, who will help me proving this? Good. Yeah. Okay, method 1. What Kalyani says, write the numerator as 2 sin square x by 2. Very good. Yeah. Next, what she says, what Anvita says, we have to express it as sin x by 2 into sin x by 2. That's what you said, right? Okay. But x is there, right? In the denominator. What shall I do? Yeah. One small trick. Multiply and divide by 2 in the denominator. Yes. Guess why? So that this will become that special result. Understood? Sin theta by theta, no? That form. Sin theta by theta, as theta tends to 0 is 1. That was the first result which I gave you. So I want to make use of that. Here, 2 and 2 will get cancelled. So I get 1. And limit of this? Sin 0. Understood? Yeah, this is one method. I think it's very effective. Can be used whenever 1 minus cos x comes. You can write that as 2 sin square x by 2. That was a very good clue. But let me show you another method also. Method 2. Limit extending to 0 of 1 minus cos x by x. Does anything strike you? Can you guess what I'm about to do? I want to try another method. Very good. Brilliant, brilliant. Multiply and divide by 1 plus cos x. Because I want to involve somehow sin x only. the numerator becomes 1 minus cos square by x into 1 plus cos x. And the numerator becomes sine square x. That is the big advantage. That was my motive actually. But I'm splitting it in the beginning itself. Splitting it as 3 functions. Hope this is fine. Numerator is sine square x, right? I chose to write that as sine into sine. And this 1 plus cos x I attached just like that with 1. So that one single term, I split it into 3. I know that limit of a product is product of limits. I can express the given function as product of any number of functions. That will help me to ease, okay, the difficulty level. After that, what will happen? This will become my special limit 1. And this is the routine 1 sine 0. This is the routine 1 cos 0. No result here. So what is it? 0 into 1 by 2. That is 0. Okay, another method. Whichever strikes you in the exam, you can use it. Both are valid. Let's pass on to the 4th result. Can you try the 4th result yourself? The 4th result is important. 1 minus cos x by x squared is 1 plus cos x. Try that. Middle. Both the methods will work. You try both. You got both the methods. Let's try first what Vignesh suggested and then what Kalyani suggested. So he said multiply and divide by 1 plus cos x. Many students do this trick, but they do it only in the numerator. They forget the denominator altogether. Do it for both. You have to multiply and divide by 1 plus cos x. Okay. What is the effect in the numerator? You will get 1 minus cos square. That is nothing but sine square. But this will stay. No, this 1 plus cos x will stay. And try to write this as product of several functions just to ease the situation. You can write this as sin x by x into sin x by x into 1 by 1 plus cos x, right? So this is the special result, this is the special result. But this needs to be substituted. That's it. 1 plus cos 0. Got it? How many of you got it this way? Multiplying, dividing by 1 plus cos. This is actually most elegant method actually. But of course that expressing in terms of half angle also will work. You tried it that way. Okay. Let us see how that works. But you should be equally comfortable with both the methods. So we don't know. In some cases that multiplying dividing by 1 plus cos x, there may not be any provision. Followed first method. We tried it previously as the first method. So try to express it as a product. Sin x by 2 by x into sin x by 2 by x. Always remember when you get a complicated function like this, if you try to write that as product of several functions, it may actually reduce the difficulty level to some extent. This actually requires a small adjustment in the denominator because the argument is x by 2. So I would like to have x by 2 here. Adjustment. Okay, here also adjustment. Now that we have equalized the denominator, the argument, result can be applied, and we see that 2 and 2, they get cancelled. This is special result 1. This is special result 1. And this 2 stays in the denominator. So far. Okay. This method, whichever you like, it's all personal preference. Okay. Both are valid. Both are legitimate. So suppose I make a small change. Of course, these results are important. Would you mind writing all the results once again? After that, I'll make some changes. Can you write all these 4 results once again? Hope you have written the results correctly. You have to understand the results very well, because I can tell you how the confusions will arise. Now I'll tell you. Okay. Let me know whether you got these right. Suppose I bring some variations. The problems are posed based on the results only, but slight variations will be there and approaches may differ. For example, I have something like this. I'll just show you some simple problems. Okay. How do you adjust this? There are 2 ways of adjusting. Let's see what strikes you first. First of all, is it 0 by 0 still? Okay. So which result will work? Yeah, this result only, but it has to be understood properly. The result says sine of something by the same thing, right? You must have sine of something, but that argument has to come in the denominator also. Yeah, exactly. I need 2 here. So multiply and divide by 2. That's the adjustment. Okay. Slight adjustment only. After that, it becomes what? That result has to be understood perfectly. The result says sine of something by the same thing, and that something should go to 0. That is also there. Okay, we have to keep that in mind. Here x tends to 0. So is it not by default assumed thing 2x also tends to 0 and x tends to 0? We can take it for granted that 2x tends to 0. So this is very much a valid result. So sine 2x by 2x is like sine theta by theta. So 1 into 2. 2. Okay. If it is something else, like instead of sine 2x, if it is sine. Yeah, then it won't be valid. If it is tending to 1, then the problem of resolving doesn't come, isn't it? For example, suppose x tends to 1 radian. 1 means 1 radian. Okay, that's what I understand. So sine 2x by x is actually a very simple result. X tends to 1. So it will be sine of 2 radians by 1. It's finite. That will be the result itself. So it's not a problem at all. Right? It doesn't throw any challenge. Or else, if you are well versed in trigonometry, sine 2x, some of you may be thinking sine 2x is 2 sine x cos x, right? Did you do that? Yeah, that is also valid. In that case, you will straight away use the result. Sine x by x is 1. So it is 2 into 1 into cos 0. You can use that result as well. Okay. Good. How did you do it? That's what your teachers will bother only about that, isn't it? Limit extending to 0. Yeah, I told you, no, whenever several functions are involved, it's better that you express them as product. Okay, that single function should be expressed as a product. After that, I know what is required. I require 3x here. So let me have 3x. I require 5x here. Let me have 5x and compensate it by having 5x. So they'd expect you to do all these. So I think now it's conducive, no, for the result to be applied. So 1 into, you may be thinking it's the reciprocal, but the reciprocal 1 is still 1. Okay, so, and then here you have the freedom to cancel x because x is only tending to 0. X is not 0, so you can cancel it. What if I bring a slight change here? Very good. That's it. You split and did it, or you did it mentally? Splitting it. Yeah, I told you to split as much as possible. No? Only then it will be easy for you. Split the given function. Feel free to express the given expression as product of many terms. Because what is valid? Limit of a product is product of the limits, right? So feel free to have 3x here. Feel free to have 3x here. So that means I should multiply by 9x. I should compensate my action. Similarly, 5x here, 5x here, compensate my action, 25x square. All these become special results. They are eligible, right? So we made efforts to bring it to the required form, the desired form. So all these become 1. And how about this? Here, x square, we can cancel. What is left behind is 9 by 25. That is 9 by. Understood? See, long back, I had a student who had actually come from a village. Okay. He had joined KVIIT and I was working as a teacher there. He was very intuitive, highly intuitive. Of course, he couldn't speak English. Okay. But very raw intelligence. And when I gave problems like this, he used to say, the answers instantaneously. Okay, if I post problems like this, he will say 9 by 25. So I knew he had understood the concept. I asked Gopal, what is your logic? He said, you said limit extending to 0 of sin x by x is 1. I interpreted this as limit extending to 0 of sin x is x. In his mind, he interpreted the result as for small values of theta, sin theta is theta itself. Isn't it true? Look at it. What is sin 0? 0. You understand what I mean? When x is very small, sin of that value is the value. So he said the sin 3x when x is small should be 3x. Okay. And sin 5x when x is small should be 5x. These two get cancelled. Okay. Similarly, the sin square 3x is nothing but 3x into 3x. Both of them are tending to 3x. Sin 5x is tending to 5x. Another sin 5x is tending to 5x. So answer is 9 by 21. And this is the way he interpreted almost every problem. See, for example, if you give him problems like this, you try this. Let me see how you limit x tending to 0. 1 minus cos 2x. Okay. Try this problem yourself. Which method are you using? Kalyani always uses half angle formula, but some of you use multiplying and dividing by conjugate, isn't it? Especially for cos functions, 1 by 9 is correct. You multiplied and divided? What did you do? Half angle. Half angle is handy, provided you are comfortable with it. 1 minus cos 2x can be written as 2 sin square x. 2 sin square 3x. 2 and 2 will get cancelled. You can express it as sin x into sin x. Sin 3x into sin 3. Split as much as possible. Okay. There may be cubic functions, there may be quadratic functions. Feel free to express them as products of several things. Then it will be easy for you. Okay, let me compensate. And then let me introduce 3 here and compensate here. All these will become 1, leaving you with 1 by. But if you use Gopal's method, what is it? Sin x into sin x, so that will become x into x. This is sin 3x into 3x, so it will become 3x into 3x. So it's 1 by 9. One minus?
You know, 1 minus cos x by x is 0. So if we take using the same logic, we take x to the
yeah, multiply and dividing by x. That's what he's saying. Actually, that's another method. You can multiply and divide by x square. Multiply and divide by x square. The last result. What is this result? Actually, it's not exactly that result. No? That was, the result was 1 minus cos theta by theta square. It's not that. So, multiply and divide by 4. And here, multiply and divide by 36. This will become half. This will become 2. They'll get cancelled. 4 by 36, which is 1. If you're very keen on using the last result, fourth result. Understood or not? How many of you understood the recentmost method, which I told you? That was result 4. Yeah, very sharp. Yeah. Good job, Deepesh. Yeah, so 1 by 9. Followed all of you. You can use any other method also. You want me to multiply and divide by x, isn't it?
Now 1 minus but when it actually RHS, it makes cos x equal to 1. So if we apply that here, I am getting the result is 1 by
You have to understand. So here 1 minus cos x by x is 0. So limit of 1 minus cos x is 0, or limit of extending to 0 of cos x is 1. But which is true, that's not any result. That's a direct result. But what he understood was sin x is tending to x is a new result which he interpreted. Understood? Usually, limit extending to 0 of sin x will be 0 only, but he interpreted it as x. That was the tangential thing. You understand? That's how he interpreted the first result. So that's very useful in MCQs. Don't use it in problems. Your teachers may not like it. Okay. So 4 problems. We have not taken tough problems so far. Okay. Try this. Will it be 0? I don't think so. Initially, it is 0 by 0. You used a half angle forms. That's only correct. By 4x. Oh, that's what you did. Extending to 0 of 1 minus 4x. Okay. Okay. Into 4x by 5x. Is it correct? That's what you did. What happens here, because it's not the single function, isn't it? There is yet another function there. And in the previous case, the leftover function went to become 0. Okay, but here there is another function. These two have to be combined. You understand the problem. This is becoming 1. Okay, of course, this is becoming 1. And this is also becoming 1. And these two will get cancelled. Understood, Kalyani? After that, you have to, this is different from that. If it is occurring in isolation, it will become 0. But here, there are two functions. Okay, so and their arguments are different. So I can't do that. But instead, what I can do is, there are various other methods of doing this. I think you would have tried it this way only, all of you. What did you do? You should have written it as 2 sine square 2x, correct? Did you all do that half angle forms? 1 minus cos A is what? 2 sine square A by 2. So 2 sine square 5x by 2. 2 and 2 will get cancelled. And you should express it as product of several functions. So sine 2x into sine 2x. And while writing the denominator also, split it as much as possible. Write them all separately. Then only you can avoid your mistakes. Divide by 2x. Divide by 2x. So compensate your action. Multiply by 5x by 2. Multiply by 5x by 2. Good. Yeah, that is a better way, actually. That makes sense. What is the other way of understanding? Sine 2x becomes 2x. Another sine 2x becomes 2x. Sine 5x by 2 becomes 5x by 2. So it's nothing but 4 by 25 by 4, which is 16 by 25. Another method. If it comes in MCQ, use this method. Okay. Sine of theta becomes theta, no? That method can be used. What is the other method that we can think of? Multiply and divide by 1 plus cos x, multiply and divide by 1 plus 1 plus cos 5x. Another method. Or else, see, when it comes in MCQs, I think you can simply remember this. Limit extending to 0 of 1 minus cos mx by 1 minus cos nx should be m squared by x. You can remember this. So remember, this will be handy as well. Maybe we can take this as the 5th result. Already you had 4 results, right? All right. I think this can be handy also. See, all these problems will be useful next year. Check. How did you get? Very good. Very good, Nitya. Hmm? You can't, because it will become it as tan x by x cube minus sin x by x cube, and x cube tends to 0 faster than tan x. So it will be like infinity minus infinity, and you'll be inviting trouble. You understand what I'm saying? So I'm saying you should not split it up in such a manner that where the denominator is tending to 0 faster than the numerator. Then it will become like infinity minus infinity. So it wouldn't be finite. So it's better to handle it as such. And what she did is brilliant. You can take sin x out and it will become 1 by cos x minus 1. See if you have followed up to this. Have you all followed? I replaced tan x as sin by cos. I took sin out. After that, limit x tending to 0, sin x into, here I'm going to take cos x as LCM. Okay, and then split this up in a manner which will be conducive. X cube, I'll allocate x here, okay, and I'll allocate the x square for this. Okay, we have to allocate functions suitably so that some result will be useful. Remember what this is, result number 1, and this is result number 4. Answer is on. I'll slightly bring a modification. See if you can try that.
Same piece, print of 1 minus cos x by x and leaving out for x.
You should combine it with x square only, because 1 minus cos x is actually a square function, isn't it? And it's coming as a product. See, that's why if it occurs in isolation, then it's fine. But if it is got other impacts, impacted by 2 other functions, no? So we have to have x square only in the denominator. Can't have x in the denominator. I'll slightly modify, see if we can handle this. What is, huh? Looks like that. Yeah, I was thinking this now. What was the previous answer? Half, no? Can you figure out the logic? What can be tan of mx minus sin of mx by x square? It's divide of any variable. It has to be a number. Huh? Answer is 2. Oh. Did you see I'm writing them as individual functions and allocating x suitably? X can be allocated here, x square can be allocated. Right? After that, what is needed? What is needed here in the denominator? What is needed? I need 4. So let me compensate it. And here, what do I need? 16, no? I need the square of this, right? After that, this is becoming 1. This is becoming half. This is becoming 1. And this is becoming 64. So half of 64, which is 30. Huh?
Yes, like 4 x cube.
You understood, right? A slight variation. I think so.
Ma'am, is it 1?
Very good, Vaishnavi. Yeah. Yeah, most of you
Ma'am,
got
I
it.
also got 1.
Very good. Very good. Did you all write sine 2x as 2 sin x cos x? That will be better. And then we can take 2 sin x out. Okay. And 1 minus cos x remains. And allocate 1x here. Allocate 1 x square here. So 2 into 1 into half. Okay. How many of you got this? I just want to know how many of you have become comfortable now. Alisha also, very good. Excellent. Excellent, Kavya. Yeah, Pranav also. How about you, Sahana? Are you okay, Sahana?
I didn't get the answer, but now I understand.
Okay, good. Limit extending to a sin x minus sin a by root x minus. Multiply. Yeah, makes sense. Yeah. Good job, Anvita. I was thinking that all of you would be doing it naturally, no? Because basically it is irrational. We wouldn't like to handle an irrational function. So can you use sin C minus sin D in the numerator? Remember the formula. What is it? Excellent, excellent. Yeah. Not many will remember properly. Correct. Is it okay for you? Huh? I just brought x minus a under the appropriate function because I know that I may have to do some manipulation here. Is it okay? I brought x minus a under sign of x minus a. Then I multiplied and divided by 2. And this 2 and this 2 got cancelled. Now x is tending to a. And this is a trouble-free term. It's not affected when x is tending to a. So substitute x as a. Here also, root a plus root a. And in between, this sandwiched function is 1. Okay. Because of the special result. So what is happening? 2a by 2. That is cos a. This is 2 root a. Answer is 2 root a cos. Followed? So we have finished almost trigonometric limits, but I'll send you the worksheet. Try as much as possible. We just need exponential and logarithmic functions and one-sided limits. That's what we need to see. But I'll send you the worksheet in any case. Whatever is possible, you do. Algebraic and trigonometric limits, you complete. Then we'll take this forward. I think we may need one more class for this. After that, we'll pass on to differentiation. Practice as much as possible. Okay, limits is not easy thing. So you need a lot of exposure for that. Okay.